Hello friends, good morning to all of you. I am Dharmendra Kumar. I teach both physics and mathematics. Whatever you will say after this class, that what should I teach? I am capable in both. I feel ease in teaching both physics as well as mathematics. That's why I have come up with a wonderful trick today in mathematics, particularly in chapter limit. I have seen that many students mug up expansion of functions in limit. That is why today I will just uh, throw away those skills which has already been contained in your mind that you have to remember overall. Okay, in order to solve the question related to limit. But today, from today onward, you will just uh, be able to you will just be able to find out that expansion yourself, but from just a single trick for which I have come up and going to upload this video. Okay, I have done BSc in mathematics honors, and I have done PG also. That is why uh, I will be waiting for your comment that what should I teach further, and should I come with such wonderful tricks, okay, for your convenience to solve the questions. That is why let's start without wasting time. The here is what you can think that limit. One thing I would like to tell you that at the school levels in the 11th and 12th, and even you join any coaching center and you read there continuously, study there continuously, and teacher tell you that the only way is what you have to remember this expansion, and whenever you will need, and you have to put that. Okay, but from today I will tell you that you will never remember, never ever remember that, and never ever mug up that and cram up that. Only you have to picturize a formula given by a scientist mathematician Maclaurin, what I will explain later. And only you have to utilize or implement that formula whenever you will think about the expansion of limit. Let's start. So limit x tends to 0, here e to the power x minus 1 upon x. You are very much acquainted with this mathematical question I have put on this paper. The e to the power x minus 1, you will be thinking there that yes, I know this, that this the value will be 1, because e to the power x minus 1 upon x, whatever will be here, e to the power, that must be in denominator too. That is why this will be and 1 must be subtracted from e to the power x. Such type of format, such format wherever you will see, and that x must tends to 0. That is why this will resulted as 1. And I have given another example that here is x, and then denominator is also x. Here is 2x, then you can't say here is x. Okay, I wrote this question like e to the power ax minus 1 upon x. Now e to the power 2x minus 1 upon x. Okay, I have hide okay uh, I have made to disappear from here right now. I will show you later that e to the power 2x minus 1 upon x. Okay, see guys, now you can't say 1, you can't say 1. See, e to the power 2x minus 1 upon x, x tends to 0 limit, you can't say 1, because e to the power 2x minus 1 upon x is not the on the pattern of formula whatever we see in the above. You can see e to the power x minus 1 upon x is equal to 1, but here is e to the power 2x minus 1 upon x. Okay, then you have to make 2x anyhow in denominator, then that will relate the original formula e to the power 2x minus 1. Then what will you do? You have to divide by 2 in whole function, and as well as for the compensation you have to multiply with 2. Now you can see this is what you wanted, This is what you wanted. And e to the power 2x minus 1 upon 2x. Here is what 2x, that is also in denominator. Now you can say the value of this will be 1 and 2. That is why 1 into 2 result is 2. Okay, but suppose you don't know the value that this is 1, then what will you do? For this type of problem, for these things that you don't know the formula, you can put directly expansion. And then another thing, then if it will come the matter of expansion, then you will think that also you have to remember expansion. But from today you will not remember expansion, but you can find out easily in a few seconds. Okay, 1 into 2 is equal to 2. Okay, here is another example. Limit theta tends to 0, theta tends to 0, sine theta upon theta is equal to 1. You mug up this and you cram up this very intentionally, that yes, I have to remember this just in order to put in formula. But I will tell you that how it will come, not with geometry but with the help of expansion we will prove this. Okay, limit theta tends to 0, sine theta upon theta is equal to 1. Okay, also you can one question I would like to tell you uh, here. Theta tends to 0, sine 2 theta upon theta. Okay, 2 theta upon theta, but here is what, that whatever is theta with sine, that must be also in denominator. So here is 2 theta, then you have to make this also 2 theta, sine theta upon theta. Okay, and then 2 is was not in question, that is why you have to compensate here. You have to compensate here. Okay, you have to multiply also, okay, with 2. And that is why this value will be resulted as what, 1, and then this is 2, another. Okay, answer is 2. Clear? But question is what, that if you don't know e to the power x minus 1 upon x is equal to 1. Okay, and if you don't know sine theta upon theta is equal to 1, then how will you put this by making like that directly? Okay, then from this just in order to solve such problem, I have come up with this wonderful trick. Okay, that trick is what, the Maclaurin expansion. Maclaurin expansion. This you are not taught in your coaching center and in wherever you study. Okay, because they do not prefer this, and even most of them don't know. And this is also for the teachers who teach students, that they can tell these things so that a student can feel ease and can just come out from that stereotypical mind sense that they have to remember anyhow. But from today they will not remember or mug up. uh, Actually they will remember a formula or a concept of given by Maclaurin, but they will not mug up at all. Okay, Maclaurin expansion. Okay, the first of all you have to know first of all you have to know is that uh, you must have basic knowledge of differentiation. You should know that how to differentiate a function. Okay, first differentiation, second order differentiation. Okay, so then I would like to tell you a little bit here. Suppose y is equal to fx is a function, y is equal to fx is a function, then differentiation is dy upon dx. Differentiation is dy upon dx. This is especially for the JEE mains and advanced students. That is why they can be availed from here, and they must was and gain something from here. Okay, y is equal to fx. Then we can differentiate dy upon dx. The literal meaning of differentiation is nothing but y is changing with respect to x, y is changing with respect to x, y is changing with respect to x. D, a small d is here, tells you that a small changes. Okay, and delta is here, large changes. That is why dy upon dx. Y is changing with respect to x. Y is changing with respect to x. It means this is the literal meaning of differentiation. Okay, you can write also dfx upon dx. Okay, you can write. And one another thing I would like to tell you that f dy upon dx can also be written as f dash x. Dy upon dx can also be written as f dash x. Okay, suppose once you differentiated these, then again you have to differentiate second order differentiation, then d2y upon dx square. You are going to differentiate again the same function. That is why once you have done, then again you have to do what, d2y upon dx square. Or you can also write down f double dash x. Okay, f double dash x. Okay, then this is what the representation of differentiation. है ना? I will need to insert this type of this type of pattern in the Maclaurin expansion. That is why I am telling you prior to coming on that. Okay, now come on that trick for which you are waiting. Okay, then here f0, whatever you will be given function, you have to put 0. Whatever you have been given function, first of all I would like to tell you the how will it okay, how will it value like that. Suppose e to the power x expansion is 1 plus x upon factorial 1 plus x square upon factorial 2 plus x cube upon factorial 3 plus dot 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 plus x to the power n upon factorial n. You also always remember this, you always mug up this, you always guys cram up this, but from today you will not cram up this, but you will be able to find out yourself, and you will feel proud of yourself that wow, I know these things. There was a curtain before your eyes that you were never uh, developed such a skill. To the power x 1 plus x, yeah, okay. That is why now again that question we have to do x0 and e to the power x minus 1 upon x. You know that answer will be 1, but how, you don't know the, but you don't know the formula that e to the power x minus 1 upon x is equal to 1 if x tends to 0 limit. Okay, you have to do what, if you don't know the expansion of this function, exponential function, you have to put down it here, limit x tends to 0 and e to the power x 1 plus x upon factorial 1 plus x square upon factorial 2 plus x cube upon factorial 3 plus dot 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 plus x to the power n upon factorial n. Okay, and here in question we have also here minus 1 in question. Okay, and x, this is what from question, this is what the expansion of exponential function. Okay, limit x tends to 0 sorry, and here is what 1 and 1 will be eliminated as plus and minus minus. Okay, you can subtract 1 from 1, that you will get nothing. Okay, now x plus x square upon factorial 2 plus x cube upon factorial 3 plus dot 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 plus x to the power n upon factorial n upon x. Okay, I think you are getting well. Now you can take a common as x from here. So limit x tends to 0, here x common, then 1, yeah, factorial 1 is the value of factorial 1 is itself 1, then 1 plus x upon factorial 2 plus x square upon factorial 3, because I am taking 1x as common, and dot 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 plus x to the power n minus 1 upon factorial n. Okay, and here is what you have to give x, then x and x, x and x you have to eliminate. Then what you have to think right now, that limit x tends to 0 1 plus x x1 plus x upon factorial 2 plus x square upon factorial 3 plus dot 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 plus x to the power n minus 1 factorial n. This was like that. Okay, now we have to do what? See here, upon x, I had cancelled, then a limit x tends to 0, 1 plus x upon factorial 2 plus x square upon factorial 3 plus x to the dot 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 plus x to the power n minus 1 factorial n. Okay, now we have to directly put the question. You do in simple limit. Okay, if you will tell me that further, I will start limit from beginning. Okay, and I will end up at the level of at j advance. Okay, then you have to uh, comment me that whether I should start or not. Okay, then 1 plus 0, here you have to put 0. The 0 will be divided by anything that result as 0, and again here x is in every term, in each term, that is why that will result as 0. Okay, and 1 will be added in multiple zeros, then that does not matter how many times zeros are there, but answer will be 1. Okay, तो देखो we saw what e to the power x minus 1 upon x limit x tends to 0 equal to 1. This was what the formula as well, but we got it from expansion. This is the benefit of expansion. Okay, and this is what I have written this formula, f0, and the whatever function you will be given, and that you have to put here 0 at first, and then you have to difference, you have to write x upon factorial 1, then you have to differentiate that f dash 0. I would like to write once here. Okay, what is the trick which I had written in on that page also, f dash 0. Okay, plus here x upon factorial 1 and f0 plus, okay, x square upon factorial 2. Here also you can write x to the power 0 upon factorial 0. Factorial 0 means 1 and x to the power 0 means 1. That is why this is the pattern basically. X square upon factorial 2 f double dash 0. Whatever is power, that number of time you have to differentiate this, and the same you have to give the factorial. Okay, this is the simple pattern. If you observe pattern, then there is nothing to remember, and this is not the rocket science as well. Okay, this is not the rocket science in fact. Okay, plus x cube upon factorial 3, and then 3 times you have to differentiate. Okay, like that, if f x to the power n and n factorial, okay, then f times n times you have to differentiate and you have to put 0. Okay, this is what the trick is. This is what the trick is, which I had written in the previous page also. Then now we have to find out the expansion of e to the power x. We don't know the expansion of e to the power x, which I related. The first thing I would like to tell you that e to the power x minus 1 upon x is equal to 1, but you don't know how, you don't know this formula, and then you can skip the question, and you can either you can get negative marks if you will do solve in wrong way. That is why. And further, if you will be told that you have to put expansion, then another question arose from you that uh, uh, even I don't know, even I don't remember, even I don't remember this expansion e to the power x, that how will I put. That is why I have come up with this trick, and you will be able to find out yourself that what should be the expansion. This is the simple trick. Okay, right now I am going to find out this. The function is e to the power x, function is e to the power x, and we have to find out expansion of this. Okay, so then what is the first term, what is the first term of my trick, what is the first term of my trick? You can, you may think that the brahmastra in Hindi. Okay, which will never miss if you will release this. Okay, and then from your bow, this is the arrow like the brahmastra, that will never be okay, that will never miss, that will kill the question, okay, yeah, related to this. Sorry, e to the power x, then you have to put e to the power 0 wherever you will find x. Wherever you will find x in function, you have to put 0. Then I put it, okay, plus x, plus x upon factorial 1, x upon factorial, x upon factorial 1, f dash x e to the power x. The differentiation of e to the power x is itself e to the power x. The differentiation of e to the power x is itself e to the power x. Then the e to the power x 0, again after finding out differentiation f dash, I told you f dash x, then x you have to put 0. The e to the power x differentiation e to the power x, that is why you have to put 0, plus x to the x square upon factorial 2 double dash. It means one, you differentiated once, then you found e to the power x. That is why again you have to differentiate second time, then also again you will find e to the power x. Dy upon dx is itself e to the power x. If you are going to again differentiate d2y upon dx square, it means a to the power x again, because you are going to differentiate again e to the power x, then e to the power x in this case, okay. Then e to the power 0 again, because the function in double differentiation it will come itself, plus x cube upon factorial 3 and e to the power 0. The number of times you will differentiate e to the powers, it will come same, plus dot dot dot. Okay, fine. And you know very well that the 0 raised to any number, 0 raised in power to any number, 0 raised in power to any number, that will resulted as 1, and you know very well that is resulted as 1. Okay, that is why e to the power 0 is equal to 1 plus x upon factorial 1 plus this is what 1 and multiplied with 1, that it will resulted as same x square upon factorial 2 plus this is again 1 x cube upon factorial 3, this is again 1 plus dot 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 plus, if you will go at n times differentiation, then it will give result factorial n. Okay, and this is what the e to the power x expansion, expansion of e to the power x. You can see guys, this is what I had put, this is what I had put here, this is what I had written here. Got it? This is what, this is what e to the power x expansion. If you don't know, don't remember in the examination hall, just the observe the pattern of this Maclaurin expansion, then and you can put, and if you know the differentiation you can find out easily, and again you can that you will take time, the few 10 seconds or 20 seconds, but it will reduce the chances to be a wrong answer, and you will get you will fetch correct marks. And this is the benefit of this expansion. This is a very wonderful, the wonderful, if you will say wonderful, then I will say wow, wonderful, it's a wonderful concept. Okay, you just think that a graph of thinking that I am thinking like that, this is a concept, a killer concept, you can say in your sense. Okay, in my sense also, killer concept which is wondrous, that is the killer. Okay, and this is what I had written f0, that you have to in the variable you have to put 0, again x upon factorial 1 f dash 0 plus x square upon factorial 2 f dash dash 0 means double differentiation, and on and you have to do on. Okay, one another expansion I would like to tell you, that suppose you have to find out a question was that sine theta upon theta equal to 1. Okay, if limit theta tends to 0. Suppose you don't know the formula that sine theta upon theta is equal to 1. But I will tell you that again you can put expansion here of sine theta. Sine theta is a function and you can put the expansion of sine theta, but you don't know what is the expansion of sine theta. That is why I will tell you the expansion of sine theta is equal to what? X minus x cube upon factorial 3 plus x 5 upon factorial 5 minus x 7 upon factorial 7 plus dot dot dot. This is the pattern, odd number pattern. 1 factorial 1, 1 upon factorial 1, है ना? If you there is no need to write power 1 or factorial because this resulted as 1. Okay, minus 1 3 5 7 with alternate sign, minus plus plus. This is what you don't have to remember. If you remember, then that is wonderful. But if you don't remember and you forget this in the, for examination, then you can find out easily. How? Because I have told you formula. What formula? F0 plus uh, x upon factorial 1 f dash 0 plus x square upon factorial 2 f dash dash 0. Okay, plus dot dot dot. Now we can put here sine theta. Here we have sine theta. Theta has replaced x. That does not matter. Any variable can bear this trigonometric ratio. Okay, this is what f0 means sine 0, sine 0. Okay, plus x upon factorial 1. F dash means you have to differentiate sine theta. Differentiation of sine theta is cos theta, and then again 0, cos theta 0, because you have to put 0. Differentiation of sine theta given function is cos, and then again you have to put 0, plus x square upon, okay, x square upon factorial 2. And again you have to differentiate cos theta, because twice you have to differentiate sine theta twice. Means once you have differentiated, then you come, you found cos theta, then you have to differentiate cos theta again, then that will be the double differentiation of sine theta. Okay, the cos theta means minus sine theta. Minus sine theta means 0 degree. 0 we have to put, okay, in every function. That this is the trick which I had